right, so today we're going to be talking about protractors and measuring angles. This is coming from section 4.4, but we're going to be starting on page 153 because we did the other yesterday. All right, so the first thing we're going to look at is a protractor. All right, so just lay your protractor out in front of you. If you look at this particular protractor, it is smaller, and actually I used to have some like that. I don't know if I still do or not. I think they've been borrowed. Well, no, actually, this is one like that that's clear. But the one that, all right, there's lots of different protractors. This you're going to be looking at today looks more like this. Okay? Now, just lay your protractor out in front of you as I am talking about protractors from the top of page 153. So a protractor is the instrument, Noah, that is used to draw or measure angles. And that's what we'll be doing with these. You can use these. I don't think we drew a lot of angles with them last year, but I'm going to teach you how to do that. But they are used to draw angles and to measure angles. Now, protractors measure angles in what measurement? What measurement does it use? No, not decimals. Degrees. Okay, like 30 degrees. You got a little mark up there in the little circle up in the top right corner that indicates degrees. Okay, now they can also be semicircular, which is what we have here. We have half of a circle, which is 180 degrees. This is what a full circular protractor looks like. Okay, we don't use these, but I do have one. And it's basically, you basically take two protractors.
Oh yeah, it's like two protractors, isn't it?
Okay, so this time I'm going to use this protractor here. Well, let's do this first. Okay, back here, and let's look at one more before we play a review game. Okay, for our science test, which is going to be Monday, guys. Okay. All right, so now we'll do some more of these tomorrow.
If it doesn't unexpectedly snow.
Okay, so we know this is my line here. Okay, so I'm going to draw another one. Okay. All right, so, without me, and it's not perfect, folks, but what, is this an obtuse angle? Yes, everyone agree it's a obtuse angle. Because if it was a right angle, then it would be going from here to here, right? It'd be making your L. But it's not. It's larger. So what is the measurement of this angle?
No, I was just going to ask. So if it's like right on the 90, would it still be an obtuse?
No, it would be a right angle. You would already know it would be 90 degrees.
So if it's 90 degrees, then it's just right angle?
Yes.
So
Yes.
is that 180 degrees?
Well, you may not. It's 110. Come over here and look on the TV a little better. Or come right here.
Okay.
Yes, let me do the talking, please. It's just like two protractors that are put together. Just like that. But they're connected. So that's a circle protractor, just like that. Thank you. Circular protractor. What we are looking at is a semicircular protractor. Now notice, guys, that your protractor measures from, everybody look at your protractor, or better yet, if you want to look on the screen, you can. You notice that your protractor starts, I'm going to start on, it would be my left, okay, right here. Notice on the outside of the protractor, it starts at 0, okay? Notice I'm going to use my little pointer here. It goes to 1, 2, 3, 4, 5, or 4 and then 5, right? So each one of these marks represent what? Yes, they represent 1 degrees. So it goes all the way, here's 10 degrees. Everybody look with me. You could look on the screen if you like. Let me get rid of this one right here. All right, now, can you see that on the screen well? All right, so notice that you start at 0. Right here is 0. Everybody look up on the TV. That is 0. It goes to 1, 2, 3 on the screen. Everybody on the screen, eyes on the screen. 3, 4, and 5. 5 is halfway between 10, right? That's 10 degrees, 20 degrees, 30 degrees, 40 degrees, and so on. So it's important to know that these protractors, each one of these lines represent 1 degree, but you have to count, okay? So like if it was on 30, this degree right here, it depends on, it would be 33 degrees, okay? Now, notice that this little dot right here is what? What is that referred to? Right here, there's an opening here, and that's referred as to your vertex. Okay, that's your vertex. So, I'm going to read the directions to you. You're not necessarily going to do this right now, but listen closely, okay? Put your book up on your desk, Noah, because to me it looks like you're going to take you a nap. So put your book up so you can pay attention. Place the vertex marker on the protractor at the vertex of the angle. So wherever the angle meets, like that point is where you're going to put this vertex mark, okay? This is not new to you because we did it last year, but it's a good refresher. Now, then you're going to rotate the protractor until the horizontal line extending from the vertex marker is on one side of the angle, okay? Now, they show you how to draw the pencil. I think I've used sticky notes before or even a ruler to help you extend your line. Then you read the scale of the protractor to see where the other side of the angle intersects the protractor. Now, if it does not intersect the protractor extended on the side using the straight edge of the protractor. Now, go down. So if the circular side of the protractor has 2 scales, notice it has 2 scales here. Okay, so you can either start from 0 here or you can start from 0 here, which might be a little confusing. But you use the scale that starts with 0 on the side of the angle that lines up with the horizontal line, okay? So I wish this was see-through, but it's not. Maybe I can try to find one online that does that. But maybe I can find one online that'll do that. But anyway, for purposes, right now we're learning about the protractor, okay? Now, notice that, let's say I had a line that was drawn like this. Okay, let me just adjust that a little, and I'm not sure if you can read that very well. But anyway, so would this angle be read as, let's say, let me put my other line here. Okay, so here's my vertex. So where is my vertex, Noah? Right there is my vertex. You see that, Noah? Everybody see that? And that's on that little dot. And that's why I wanted you to use the plastic one today so that you could see. The vertex is right here, okay? This is my angle. Okay? So when I took my protractor, everybody look, first I put that dot or that opening on the vertex. And then I lined it up. See, you got a line here and a line here. But you want to line it up like this. You'll know how to do it. And then you're going to see where the line goes. Now, so would this angle be read as 112 degrees, or would this angle be read as 63 degrees? What do you think, Ezra?
I don't know.
112 degrees?
What type of angle is that by looking at it?
Right.
It's less than a right angle, so it's what?
Acute?
Obtuse, or acute. Yes, it's acute. So you know that you're going to be reading the smaller side, right? Okay, so with that said, it is going to be right here, which is 63. Okay? Now, let me show you something here. I've got a right angle here with my blue angle. Okay? Now, so what is a right angle? How much does a right angle measure? Look right here. 90 degrees.
It's an L shape.
And it is an L shape, but it is a right angle, okay? So we know that is exact 90 degrees. But if this line was if I move this blue line this direction, and it was going from here to there, okay? So, in other words, forget this line for the moment, okay? But the vertex is still here, okay? But my line goes up this way. Everybody look at it. What could the measurement of this angle be? It could either be 119 or it could be 61. How do you know that it's 119? Because it's an obtuse angle, right? That's why you have to recognize what an obtuse and an acute angle is, okay? In order to be able to determine, well, I mean, there's other ways you can do it, but this is the easiest way, I think, right now that we're going to learn with the protractors. You got to know if it's an obtuse or acute angle in order to read the protractor, okay? All right, let's do another one. Now, let's just quickly talk about these angles and if they are acute or obtuse, okay? So notice that you have your straight line here, right, of your ray. Everybody look, Noah, look. Okay, now, is this the vertex, right?
Yes.
Okay, and then the other angle is going this way. So is this an acute or obtuse angle?
Obtuse.
Why do you think it's obtuse?
It's bigger.
Is it bigger than a 90 degrees?
It looks bigger.
Okay, it is not. Let me show you what a 90-degree angle is.
So it's acute?
It is acute. Remember, and just like you said, Mr. Noah, a 90-degree angle forms an L, okay? It really does. It does look like an L, okay? See, that's a 90-degree angle, Noah. Now, look at this angle here. Is this smaller or larger than this 90-degree angle?
A little bit smaller.
Yeah, so that makes it acute, right? You can scoot over here if you need to see better. How about this one? Is this an acute bear or an obtuse angle? It is cute.
That looks the exact same as acute.
It is an acute, but it'll measure differently, okay? How about this angle, Ezra? Is this an acute or an obtuse angle?
Obtuse.
It's obtuse
That's obtuse.
because it's larger than a 90-degree angle,
It's
okay?
longer.
Yes, yes. So does everybody understand that? All right. Now,